So let's say that we have the interval 833 cents, and we want to know what JI ratios it's nearby. So what simple frequency ratios that this approximates. Now we use cents as a way of measuring pitch distance because we hear logarithmically, so it's useful to have a logarithmic measure of pitch distance. And also it makes the math easier. So you could add this value to any other number of cents that is the same as multiplying the frequency ratios. So a semitone is 100 cents, 12 semitones is 1200 cents, and so an octave, which is double the frequency ratio, is 1200 cents. And so we want to convert this number here, 833 cents, back into a frequency ratio, or to get an approximation of it. So first we want to divide it by 1200. So 1200. And that gives us approximately 0.69417. So this is our logarithmic portion of an octave. So it's 0.69417 of a logarithmic octave. Now we want to raise 2 to this power, so we go 2 to the power of 0.69417 to give us our linear frequency ratio, which is 1.618. And so now we have, this is essentially our fraction. This is if we had 833 cents as a just intonation ratio, it's about 1,618 over 1,000, or 1.618. But that's not particularly helpful. We want to know what simple ratios is nearby. And so that's particularly useful when you're working with temperaments, where you want to work out, so you might be working in, say, 36 equal temperament, you have access to a value of 833 cents, but you want to know what simple JI ratios you can use it as an approximation of. So the easiest way to do that in this case is to use a continued fraction calculator. It's easier than calculating the continued fraction by hand, and honestly, unless you love long division, there's not really much point doing it by hand. So I've put up a continued fraction calculator here, and in this box here you can enter in a decimal number, so we'll enter in 1.618, our fraction that we got earlier. We can do denominators 1 to 100, that'll probably be fine, and then we can show the smallest denominators. And so you can see down here, it gives you an increasingly accurate list of truncations of the continued fraction. So they're like approximations of our value here. So if we look at the top, the first fraction that it approximates is the octave 2 on 1. Obviously that's not very accurate. And then 3 on 2, 5 on 3, 8 on 5. So you can see that they get more and more accurate. Eventually we get to the point where it's, say 13 on 8 is not too bad. You can't see the error here, but 8 on 5 is only 1% error margin. So you can see it's 1.6 compared to 1.618. By the time you get to 13 on 8, you're less than 0.5% away. So you're 1.625 compared to 1.618. So that's not a bad place to say, okay, maybe we can use 833 cents as an approximation of 13 on 8. We could also use it as an approximation of something like 21 on 13, but then obviously that's a bit more of a complicated ratio, and so you might have to be a little bit more discerning when you're using that in your music. So let's call it an approximation of 13 on 8. Obviously, if you put it in a chord that reinforces that character, so say you put it in a chord that also has a 5 on 4, so that's a major third, that could also be 10 on 8, or that's a de-simplification of it. So that would make an 8 to 10 to 13 chord, and then you could add a 3 on 2, which is a perfect fifth, which would make it an 8 to 10 to 12 to 13 chord, and so that would give us a harmonic 13th chord, and that would help strengthen the character and make the 833 cents feel less out of tune and more stable in the chord. So say we've got our 13 on 8, and we want to convert that back into cents so that we can compare it. So first we take the log base 2 of 13 on 8, and that will give us our logarithmic ratio. Now, I don't have log 2 in my calculator, so I just take the natural log. So this is just a handy little log trick. You can do natural log of your ratio, so 13 on 8, and you can divide that by the natural log of 2, and that converts your logarithm into a base 2 logarithm. So that's how I do this log 2. But if you have a calculator that will do any base log, then that's fine. That'll give us about 0.70044, and then we can really simply just go this value times 1200 cents will give us 840.5 cents. And so we started with 833 cents. So you can see that they're quite close, or they're close enough for most purposes. So if we subtract those, we'll see that our approximation that we chose, our 13 on 8, is 7.5 cents away. So 840.5 minus 833 is 7.5 cents. And so that's 7.5 hundredths of a semitone, or about a 13th of a regular equal temperament semitone. And so it's not a bad approximation. So you could say that 833 cents could be used as an approximation of 13 on 8. Now, where you choose to draw the line and how many cents you say is too far to be usable anymore is very arbitrary and completely up to the individual. And it will depend on things like timbre, how long you sustain the chord for, all sorts of factors. What other ratios are in the chord that might reinforce or add ambiguity to the ratio. So there's a lot to consider there. But yes, this, I would say 7.5 cents is usually good enough that you would hear it as a detuning of something like 13 on 8. Now we could do the same process for something like 21 on 13, and that would give us a different approximation again. And it would be closer to 833 cents. Because generally as you go down, as I showed earlier, as you go down those truncations of the continued fraction, you'll get closer and closer approximations of this cent value that you plug in at the start. But obviously 21 and 13 is a bit more complex, and so the average person might not hear it as being as stable. So they're all things to consider when building chords, but any of those options could be usable under the right circumstances. So just a quick recap. 2 to the power of the interval in cents divided by 1200 will give you a fraction that you could use to compare in just intonation. And 1200 times log 2 of the fraction will convert your interval back into cents, which is your logarithmic representation. So the fraction is a linear representation. That's how you compare ratios that you'll find in the harmonic series, or rational frequency intervals. And your interval in cents is a logarithmic measure, which more accurately conforms to the way that we hear pitch distance, and makes the math easier. So you can add intervals in cents together to give you an approximation. You can add intervals in cents together to give you a new interval in cents, which is equivalent to if you had multiplied their fractional frequency ratios. So if you take the fraction, you plug it into a continued fraction calculator like I did earlier, that'll give you successively better truncations of the continued fraction. So essentially it'll give you better and better approximations of that fraction that are simpler than the fraction. And you could use an irrational number here as well. So when I say fraction, I mean you could use an infinitely long decimal if you had an infinite amount of time But obviously you could use a really long decimal that doesn't really have any meaningful rational approximation and plug it in and still get a good fractional approximation of it. And with the intervals, in a sense, it's very easy that you can just take two different intervals that are nearby each other, subtract one from the other, and it'll give you the difference, and you can use that as a measure of how close your approximation is. So if this was helpful, let me know, and I'll do more tutorials on microtonal math and other interesting microtonal stuff. I think this is a really handy tool to know. I've noticed a lot of people seem to be unsure how to convert between fractions and cents, especially how if you have a number of cents to be able to approximate that with a fraction. So hopefully this is helpful in building your own microtonal scales and understanding equal temperaments and how they approximate just intonation a little better. And also how you can see how, more complex ratios in just intonation fall close to simpler ratios in just intonation, and how you can convert those to cents and you can compare them really easily. And see how, some really big, complicated just intonation number might actually be near, or some big, complicated just intonation ratio might be near something much simpler, and so might be heard as a slight detuning of that much simpler one without, enough reinforcement to induce the character of the more complicated ratio that it actually is. So yeah, hopefully that was helpful. Make sure to leave a like and subscribe if you find this helpful, because I'll definitely look into doing more stuff like this in the future. Bye.